Hello there. My name is Craig Resnick, coming to you today from the ARC Advisory Group. Pleasure to be with you here today at the Accelerate 2025 GE Vernova Proficy Software Users Conference. And today we're going to discuss trends in smart manufacturing and operational resilience that are aiding manufacturers and processors and OEMs with their digital transformation journeys. These are companies must adopt a smart manufacturing and operational resilience approach. But what exactly are the key trends in smart manufacturing and operational resilience that help these companies navigate their digital transformation journey? I mean, this includes best practices, technologies, tools, and solutions available to help these companies successfully navigate this journey and adopt and deploy and scale these technologies. How do these companies ensure that they're operationally resilient, and how do they navigate the technical and cultural challenges that these journeys bring? So, to identify these trends in the fourth quarter of 2024, ARC surveyed 591 senior executives from manufacturers, processors, and OEMs with roles in OT and IT. They were located globally. Most companies had over 250 employees, and respondents came from over 16 vertical industries. So pretty well dispersed between process industries, hybrid industries, and discrete industries. The first question was to choose the top three priorities of their organization's smart manufacturing and digital transformation strategy and vision and their roadmap and their top priorities that they came back and the responses were excellence in delivering quality products and services, as well as operational excellence in supply chain, distribution, finance, and production, focusing on improving operational performance and resilience. These results are driven by the numerous operational challenges in manufacturing and the supply chain, such as more complex processes, increased traceability and serialization requirements, issues like capturing mislabeled products, the growing global government regulations regarding safety and traceability and sustainability, and greater requirements for agility and responsiveness due to the changing consumer demands and supply chain issues. Supply chain issues can include sudden changes in cost due to tariffs, availability issues due to geopolitics or natural disasters. Digital technologies such as artificial intelligence and IoT, are used to help address process improvements and production expansion. So getting back to the survey, the next question was to choose the top three initiatives that will significantly drive investments in their organization. Their top priorities were growth, expanding into new markets, segments, and geographies. Then innovation, like it's creating new products and services, and then energy transition and sustainability, focusing on improving operational performance and resilience. These results were driven by making investments in technologies that can help address, for example, process complexity, which can constrain in achieving safety and quality goals. Technologies such as digital twin, augmented reality, virtual reality, analytics, artificial intelligence, and machine learning, used to design and control and operate complex processes. For example, simulation technology is used for more efficient model building of complex processes, design performance validation, operator training, and advanced operations. And the result of these investments has reduced product variability and improved performance, and also reduced production risks and downtime. The next question is about smart technologies that are currently transforming manufacturing organizations and those that are going to have a significant impact within the next 3 years. So going into 2025, these technologies such as, cloud computing, analytics, 5G, industrial Internet of Things, sustainability tracking and reporting, artificial intelligence, and machine learning, are already beginning to have a significant impact. And then when we get into the next 3 years, we expect to see a greater impact of technologies such as digital twins, robotics, industrial metaverse, and augmented reality and virtual reality, as well as the next generation of cybersecurity technologies. But other technologies emerged as well, such as open and virtualized automation systems. And let's we'll talk a little bit about technologies such as say augmented reality, where the respondents really believe it'll be used to enhance the customer experience with people who are using their own products. But additionally, they felt this would also be a great tool to assist their employees with increasing production and efficiency, as well as helping them to try to simplify operations as well. The future in open automation technologies looks promising. When asked if these technologies will be part of the, future RFQs or requests for quotations, respondents chose, NAMR module package type and the OPAS standard. NAMR is developed by the User Association in Automation Technology and the Process Industries, primarily, driven from originally from Europe. And it provides guidelines for standardized equipment models and description language to streamline interoperability. And the MTP enables easier integration of distributed control systems or programmable logic controllers, kind of reducing the time and the cost to integrate distributed process and reliability assets and equipment. The OPAS standard is developed by the Open Process Automation Forum, or sometimes called OPAF, and that defines an open, interoperable, and secure architecture for industrial process automation systems. It aims to create a standard of standards, shall we say, by using existing and emerging standards whenever possible. The OPAS standard, includes reference architecture, information models that enable distributed and heterogeneous ecosystems of industrial process automation resources to try to incorporate them all together, and again in an open environment. Another thing that we that really popped up in our survey was the future of virtual automation systems such as PLCs and DCSs really looks promising. When we started to look at expectations of the users and we started to say let's project out say to 2030. And as you can see from the survey, over a third of the respondents felt that there's about 25% of all controls by 2030 could be virtual, and another third said they could expect up to 50% of all controls could be virtual. It's obviously something is 5, 10 years ago, we certainly would not have predicted would have been that high. We're obviously with a lot of emphasis on doing control, virtually. And when we start talking about technologies that will have the largest, impact on manufacturing over the next 5 years, industrial artificial intelligence certainly stood out significantly. Industrial artificial intelligence. And AI is expected to have a major effect really on all technologies as it gets incorporated as an embedded feature in virtually all technologies, whether it be, cloud, energy, robotics, edge computing, analytics. But I think every technology is certainly going to have an artificial intelligence, component going forward. Another thing that we started to look at, which is, certainly been rapidly growing, certainly over the last several years, has been, the progress that companies are making with their information technology, operations technology, and engineering technology convergence initiatives. Companies that we at ARC look at as leading companies in this area have really made significant advancements across most or all of their facilities, with this convergence. In contrast, companies that we might consider to be mainstream companies have made progress in really only a portion of their facilities, maybe a single facility or a small number of their facilities. And then companies that we might consider to be laggard companies that either have not yet started the convergence process or really have only made a limited process, maybe in maybe just a small subset of their facilities. And then we started to look at what are the critical components that's driving these initiatives for IT/OT ET convergence. And the most cited technology that was driving this convergence has been cybersecurity. A lot of that's driven by um, IT, which certainly has an expertise in that area. From a legacy perspective, the growing use, of course, of artificial intelligence and cloud technologies. So those are the things that have really been spurring this on. Where organizations really require the highest levels of cybersecurity to ensure IT/OT ET convergence is fully secure. And the cloud serves as the hosting platform for knowledge bases and that's really enabling a lot of this convergence, where artificial intelligence provides generative and large language models to allow the workforce to productively and efficiently leverage data and information from these knowledge bases. Mainstream and laggard companies cite the critical components for supporting IT/OT ET convergence initiatives, with even if it is in lower numbers. And when we're looking at, for example, what they felt as though that with the technologies that really are going to have the greatest impact as a result of IT/OT convergence. And they felt as though that the resulting of having greater productivity, reducing cost, and enhancing quality would be the byproducts of IT/OT ET convergence. And that's really where you're going to see the greatest effect, based on these IT/OT convergence initiatives. We also started to get into and started to explore the role of MES in both smart manufacturing as well as operational resilience. MES really emerged as a key application, playing a significant role in IT/OT ET integration and convergence, manufacturing intelligence, advanced analytics, and artificial intelligence, and digital transformation and energy management. And I think this highlights MES's pivotal role as a driver of smart manufacturing and operational resilience initiatives. And when we were asking which MES applications would benefit most from incorporating artificial intelligence, respondents identified manufacturing intelligence, reporting, visualization, digital dashboards as key areas. But additionally, performance analysis and quality management were also highlighted as big beneficiaries of artificial intelligence, especially as it incorporates with MES. And and really getting involved with the use with MES and the use of artificial intelligence in production operation initiatives. Companies today are concentrating on artificial intelligence in production scheduling, quality control, process optimization, waste reduction, and preventative maintenance. However, in 3 years, the digital twin metaverse is really expected to become also one of the primary initiatives to this as we get into as we get into MES. We also inquired. Somebody has to pay for this. And so we were asking questions regarding we are the primary funding source for the company's technology and services to support these smart manufacturing and digital transformation initiatives. And IT emerged as the leading source of funding by a significant margin. So while all the budgets certainly are used and can contribute to digital transformation, but IT still and we is expected to remain the predominant funding source for these digital transformation and operational resilience initiatives. As the surveys indicated, operational resilience is essential for a company's survival and growth. Any company's digital transformation and sustainability journey must ensure resilient operations to overcome potential business risks. These risks include, continuous cybersecurity threats, unscheduled downtime, supply chain disruptions, extremes in weather and climate change, safety issues in the plant. Could also be as a result of geopolitical issues, whether it be, tariffs, trade embargoes, and leveraging technologies such as artificial intelligence is crucial for increasing operational resilience. So we say, what is operational resilience? And it's a methodology to make sure you're effectively prepared for and manage both for expected challenges and unexpected challenges. Sustainability encompasses decarbonization, GHG tracking, ESG reporting, circular economy, energy management, ethical sourcing tracking, and environmental, social citizenship. And companies must adapt, quickly and rapidly to rapidly changing consumer requirements and demands, and ensuring these operations can withstand and recover from disruptions is really critical for increasing operational resilience. Managing increasing complexities such as product and packaging variance, supply chain volatility, and cost control is especially in high inflationary times is essential. The addressing workforce issues such as skills mismatch and change management, demographics, connectivity, and the impact of certainly many people early retiring or leaving the workforce is really important. And protection against the continuous cybersecurity threats and achieving year-over-year improvements in metrics in operating efficiency are certainly key priorities. So, ARC has an operational resilience model, focused on four key areas. Secure connectivity ensures cybersecurity and data integrity, preventing data tampering or theft, and maintaining a single version of the truth. Infrastructure performance guarantees excellent asset condition to maximize productivity, quality, and sustainability, and the delivery of services and products. Supply chain integrity is maintained regardless of geopolitics, tariffs, climate change, to kind of avoid the best you can supply chain interruptions. And lastly, predictive serviceability involves remote and secure monitoring, control, and the servicing of assets with the ability to predict failures, before they occur. And we also asked the respondents about their energy transition and sustainability initiatives. Today, their top initiatives are improving energy efficiency and optimization to lower costs while incorporating sustainability into supply chain design and operation. Looking ahead 3 years, the focus will shift, I think, more towards meeting things such as net zero and ESG reporting mandates, and more so and more rapidly transitioning to, clean energy as more of a primary energy source. Many energy transition and sustainability drivers are a result of, consumer pressure for sustainable products, green products, clean energy choices and renewables, then things like government regulation, for example, for single-use plastics, fuel standards, carbon taxes, for example. But also, investors are looking for sustainability portfolios and ethical investments, and the effects of energy in transition, such as on clean energy, land, water management, low carbon businesses and products, as well as the effect on sustainable products, such as with regarding circular economy, reduce waste, lower water consumption, and lower carbon dioxide emissions. And the benefit of operational resilience, stems from effective preparation to manage both today's and tomorrow's challenges, whether they're expected or unexpected. These benefits include, fewer process upsets, greater cybersecurity, or improvements in production, lower energy consumption, a more reliable supply chain, and improved stakeholder expectations. Fewer product reruns, less rework, more efficient raw material usage, improve waste elimination, leveraging circular economy, marching towards net zero and ESG goals, and protecting against the only certainty, and that the only certainty, of course, is uncertainty. And in summary, the best practices in smart manufacturing, and enable a focus on the you know on the workforce. Go back to the levers back. And in operational resilience, able to focus on collaboration and reduce complexity. Because attracting a new workforce by deploying smart manufacturing technologies and getting smart technology in the hands of the workers, and enhancing collaboration by allowing remote experts to participate and improving efficiency and providing information to connected workers, and reducing complexity through knowledge capture management and reducing paperwork and incorporating in deploying new workflow processes, utilizing artificial intelligence and real-time visibility and information and monitoring tools to kind of meet these challenges of assessing operations and more agile production. And this is the surveys, when we look at starting the 2025 technologies and trends to and trends to watch, you're certainly going to see a big focus, continuing growing focus on industrial artificial intelligence, mainly the use of things such as co-pilots, industrial control and computing. I think we talked a little bit earlier about the growing use of virtualized controllers. The human in the compute environment, and more and more emphasis on the connected workers and on things such as autonomous operations. But this is a case where you really bring AI in to kind of enhance process automation, for example. Continuing emphasis, of course, on cybersecurity and leveraging solutions, especially in the industrial edge and networking infrastructure. As far as the growing deployment of using analytics, deeper analytics for industrial data, maybe even pulling in some additional computing technologies, like maybe finding some more practical uses for, say, things like quantum computing. I think the whole robotics, whether it be automatic guided vehicles or AGVs or AMRs, to really help, especially in material handling applications or automated warehousing, and certainly a greater focus certainly on sustainability and energy transition as well. And in summary, what we're really seeing is that the industrial companies are responding to these market pressures. Whether it be the greater supply chain volatility or evolving. As the customers' demands continue to evolve and change. Any other government and energy regulations. The continuation of the evolution of the workforce getting smaller and less experienced, and really requiring more tools such as AI to be and augmented reality and virtual reality to do their jobs better. Again, a world which really requires, for either climate reasons or geopolitics, that requires greater operational resilience. And then this just having to come continuous pressures to accelerate innovation, and using these solutions, and getting to the point where what you're really doing is you're really developing, using these systems and technologies and the continual proliferation of new and changing industrial platforms. And whether it be in digital, whether it be for artificial intelligence, sustainability, also a shift from selling products to what we call servitization, where you're actually becoming pure service providers, and maybe not selling any physical or hardware or software products per se, but obviously really just getting into the business of only really being a service provider. Key systems and technologies, including, with data models and analytics, enterprise software and engineering and plant software. And I think the things and having to deal with this evolution technologies, and really is creating kind of additional disruption. And that's in that. And what kind of innovation does it take to kind of deal with some of this disruption? And because of obviously the severe impact this disruption has on people and culture and the workforce and business processes, per se. And when we look at things such as artificial intelligence, and just to sum it up, what are some of the benefits that people are seeing from AI is to kind of gain that competitive edge, from whether it be reduced costs or ways of improving, product quality, use on the energy side for lowering emissions and helping to do a better job managing and securing their supply chain, shortening the time to bring products, to market and attract talent because it's really being used as a tool, whether it be through generative AI or large language models, but to better educate the workforce and make that workforce, more productive. And here are just some examples of AI applications, which are ranging, from robotics to data fabrics to, building, AI specific, platforms, whether it's use in in R&D or for, autonomous or agnostic platforms, both for machine and physical intelligence, computer vision platforms, but you're going to really be seeing the full proliferation of AI, into virtually every single application in manufacturing, and this is going to be kind of a common denominator, completely across, and completely across the whole spectrum. So with that, I want to thank you very much for listening today, and if we can be of any help, and hopefully get a copy of the slides so you can certainly look at some of the data with in a much as you have time, and again, thank you so much, and look forward to the rest of the conference. Thank you so much. This is Craig Resnick, ARC Advisory Group. Thank you so much. Have a great day.